Hey, hi everyone. So today we are going to discuss about this RAG in the generative AI space, and I will give you the little overview about it. So RAG is basically stands for Retrieval Augmented Generation, and we'll discuss about what is this RAG and why it is required. So if you know, around 95% of the world's data is private data. So whatever we can see in the Google or any browser, all those are the public data, and LLM is trained on that particular data. Okay, and also one thing, LM is only trained till some particular date. Okay, suppose if this GPT-4 Turbo, it's around trained till uh, 23, right? Some June 23 have the data till date. After that, doesn't what are the recent event happened doesn't know. Like just for this, if I'm asking question related to this Paris Olympic 2024, right? So it doesn't have this data because that's a very recent one, like 1 month, 2 months back. So in this all this particular case, we require to feed our own data to the LLM because there are multiple clients or the companies, they have their own personal data, right? So but LLM don't know anything about it. So if a user is want to ask any question related to it, so LLM unable to give the answer. So for that we need to feed those data to the LLM. So in this case this RAG is required. So this is basically the process or the mechanism where uh, we are trying to feed those relevant data to the LLM so that LLM can able to generate answer from it. Okay, so I will just give you the high level walkthrough, like what exactly retrieval augmentation is doing. So it's basically divided into the two part. First is retrieval, and then another is like what are the retrieval. From that, it will try to generate this the generation part, right? Using the LLM. So in this first part, we have this private data, okay, or what are the data we need to feed to the LLM, okay, which LLM don't know anything about it. So those data we can store in the form of the vector DB. I will explain it in detail later stage. Okay, so whenever user asks any query, right? So using that query, a retriever like will try to retrieve some top three related documents from it, which is related to our query. Okay, so that we considering as a some context. Okay, and after that what we are doing, what are the prompt or the query we have, along with that we are passing that particular context, that retrieved document, to the LLM, so that LLM will generate the answer for that particular query using those particular context. Okay, or what are the instructions we give, based on that it will try to generate the answer, and at the end we'll get the response. So this is a very very high level. Maybe there are certain advanced techniques are there, but that we definitely will discuss in the later stage. This is the only the overview uh, a video of the rack. Okay, so what is exactly happening in the vector DB, like how we are creating it. So first, what are the documents we have that we are splitting into the chunks? Maybe we cannot send all the documents to the LLM, right? We can't pass because there is a context length limit to the LLM. So first we need to split it, and then using the embedding models, we are getting this embedding so that whenever user asks any query, we can find the relevant data, okay, which is related to our query. And then once we have this all this embedded vectors that we are storing into this vector store or the vector DB, you can say. Okay, so this is about this indexing part, and this is the retrieval and the generation part. So here, what we are doing, what are the questions user is asking? We'll retrieve some top three or top four. What are the documents we need related to that particular query? Then we are creating this prompt using that query and what are the retrieve document, and that we are passing to the LLM, and LLM will generate the answer from it. Okay, so let me just give you the code walkthrough how it's working. So yeah, here we are going to use this LangChain. That's a AI framework. With we can use. Maybe we can discuss this later. Okay, in the very detail. But yeah, that's basically we are using here. And here I'm also using this LangSmith. Basically, it help in trace our all the requests which are goes to the LLM. So at least we know like what is exactly we are passing to the LLM and what the response we are getting and what are the happening in between. Okay, so for that, yeah, we need to For the long chain tracing version 2, we need to set up as a true. And long chain project, I'm currently passing as the RAG overview. And this long chain API you need to set. Okay. So this I already set up, so I'm not running this one. Then what I'm doing, I'm just first we need to create this language model. Okay, so you can use anything like OpenAI, Cloudy, or any other OpenAI model. I'm currently using this chat graph. That's Llama 3 8 billion parameter currently I'm using. Okay, you can use anything, whatever you want. Then after that, I'm setting this embedding model. Okay, where I'm using this core embedding, which is using this embed English version 3 model. You can use text ADA or any other open LLM you want to use. Okay, after that we comes to this RAG part. Okay, so here in this RAG, what is happening? uh, I think we already discussed like how we are creating indexing and how the retrieval and the generation is happening. The same things I will show you. So here we have this one file. It's a rag whitepaper.pdf. Okay, so first we are loading. It's around 10 or 16 page of PDF, and that we are loading into this particular loader. Okay, and once we have that document loaded, then we are splitting into this chunk size of the 1,000 character. Okay, this one I will definitely explain you in the detail, so no worries about it right now. And once we have the splitted document, those we are sending to this embedding models. What are the embedding models? This core we currently using, and it will generate vector embedding for it, and that we are going to store into this chroma. So it will create basically one index and the vector db for us. So we are storing into the vector store variable, and using this we are creating the one retrieval. Okay, so basically we are passing the our query to this retrieval. So here I will just quickly show you this rag chain we have. Okay, here we have this retrieval as a context, and the question that we are passed at the runtime. Okay, so this particular question, whenever we are running this chain, right? So we are passing this particular query, is how to optimize the RAG. This is the question which I'm asking. And first retriever will take some top 4 documents, okay, which is related to this particular query, that we are sending to passing to this prompt. Then prompt will pass to the LLM, and what is the response we get from the LLM? Uh, Using this string output parser, it will pass that output and it will show you here. So to optimize the RAG, you can try to this the response we get from the LLM. Okay, so LLM doesn't have any information regarding this RAG white paper. Okay, because this is recently published or something. I mean, I just took the just for the example. Okay, so now I will show you like what exactly happened in between, like all the transactions, how is exactly happening. So if you can see under this RAG overview project, I have this one. This particular transactions happen, and in this particular request, this is the input I'm giving how to optimize this RAG, and this is the final output I got. Okay, so what happened in between is this. This is the retriever. So in this retriever, I'm uh, let's load it first. Yeah, so how to optimize this RAG that I'm passing to the retriever. So yeah, after that, this retriever will retrieve this 4 document which is related to this particular query. So we have this total 4 documents. Okay, so like this is from the 16 page number, this is from the 17 page number. Yeah, these are the maybe related to this one. Okay, so that's once we got this one, uh, that we are passing to this particular LLM. So how we are passing? First, we are getting the prompt like you are an assistant for question answering task, blah blah blah. So this is basically the instructions we are giving. This is the questions we have, and this is a particular context. Okay, that we retrieve from the those total 4 documents that we are sending. Okay, and at the end, we are getting this as a response. Okay, to optimize the RAG, you can try the following store, document index, and vector store on CPU, like blah blah blah. Okay, whatever. It able to generate the answer. Yeah, so this is all about today's video. We discuss about this RAG overview, what is happening in the RAG at the high level. Please comment in the section like if you have any query related to it, or if you need any kind of video related to something else. I will definitely try to create. Okay, and please like, share, and subscribe, and please support this channel. Yeah, thanks for watching.